Hey everybody, today we are going to be working on the University of Waterloo CCC 2020 Junior 2. So it's kind of ironic that they made this year, and they made this before the recent world event that's happening here. I don't want to get demonetized by YouTube for this one. But basically it's studying epidemiology, which is the rate of transmission of disease, right? Or it's a study of disease. So what they're doing is they're modeling how fast a disease can spread. And so essentially you're assuming that you have a population that's essentially unlimited, all right? But what they want to know is how long will it take to infect a certain number of people. So the number of people that they're targeting, the target number of people is P, all right? The N value is the number of people who have the disease to start with. And the R value is the rate of transmission, which is how many people is expected that each one person would spread to. So if you have an R of 3, it means each one person is predicted would spread it to 3 others. That would actually be really, really big. All right. So if we look here, what they're saying is that we're looking for a target to say how long will it take for 750 people to get the disease if one person had it and it had an R of 5. So they explain here that on day 1, that one person would have infected 5 people, right, on day 1. So on day 2, now you have those 5 people that now will infect 5 other people each, so then they'll have 25 people infected. However, the one person does not infect other people again, right? And so what you had on day 2 is you have 25 people who now have the disease, but 6 people from the previous days that still have the disease but do not spread it, right? So on day 3, it's those 25 times 5, but the other 6 people did not spread it either, right? So this is kind of a way of simplifying the problem. And they want to see how long it takes before you reach this target number, this critical number that they want to find, 750. All right, so in example 2, what they have is like, how long will it take for 10 people to get it if 2 people start, but each person infects 1 person per day? All right, and so they're saying it will take, 5 people, or 5 days, right? So it makes sense. You have 2 people on day 0. On each day, 2 other people are infected. So on day 2, you've got 4 people. On day 3, you have 6 people, then 8, then 10. All right, so, okay, let's go take a look at how to solve this one. So essentially we have 2 different groups of people. So we've got spreaders, okay, so people that can spread the disease, and also non-spreaders. All right, and that's pretty much it. We also need integers for the R value, so the rate of spread. Okay, and our target population. Now, we're not actually targeting a population. We are actually just looking to see like how many people, like how long before it would take for that to spread to so many people. We also need a variable to track how many days have elapsed. All right, so I think that looks pretty good. Okay, so let's just see what happens on one day rather than working on every day. So on one day, our day is going to go up. So I'm going to go to day 1. So what happens? Well, our non-spreader, or our spreaders, turn into non-spreaders. All right, so the non-spreaders plus equals the spreaders. So the previous day's spreaders, which were these guys, become non-spreaders. All right, but they also, before they become non-spreaders, or we can do it right after, they also spread the disease. So the spreaders times equals the rate of spread. Okay, so if the rate of, like, let's say we start off with 1 person. Okay, so we have 1 person, so we'd have 0 non-spreaders to start, 1 person who could spread the disease, and let's say the rate was 5. So what would happen is that the non-spreaders, so that one person would go into the pool of non-spreaders, but they would after that infect 5 other people. So then the spreaders would be 5 for the next day. All right, and what we are going to do is we are going to loop this, and we're going to say while the spreaders plus non-spreaders, that's the entire diseased population. The entire population that has the sickness is spreaders and non-spreaders is less than. Let's go. We have to go actually take a look at the assignment again to see is it less than or equal to, or is it just less than. Okay, so let's go take a look here. It says, and I'll bring this over so you guys can see it. Okay, 300 first days. Okay, more than. Okay, so here you can see it says we want to determine when a total of more than P people have had the disease. So not equal to, but actually more than. Okay, so more than the target population. All right, so as long as there are fewer people than the target number, then we're just going to keep on going and seeing like how much this disease spreads. All right, and then after that, the while loop should end, and we should just see out the day, right, to say how many days would pass. Okay, now before we do this, this is going to go on forever because everything will be 0. So we need 3 inputs. So we're going to say cin the target population. That's as per the question. So cin the let's see. Sorry, I have to go look. I'm looking at the problem to see what the rate is. The first one is the spreaders. Okay, so how many people can spread the disease? And then this third number is the rate. And it says rate or spread up there. So I need to go change that. Rate of spread. Okay, and let's test it out. So in the example, the first one was 750.15. So the sample they gave us, 750.15, and the answer should be 5. Oh no, 4. Yeah, that's right. Okay, and in the second one, the second example they gave us, the inputs were 10 to 1, and the answer should be 5. Oh, 4. Okay, let's take a look and see what happened. Okay, so what we can do is we can actually just put some, let's actually just track what's happening here. So we're going to say see out the day and take a look. And I think what's happened will become apparent here. So we're just going to say what the day was, and then we're going to say the total number of people that were affected. That's the spreaders plus non-spreaders. Okay, let's take a look and run the program. So okay, so for the first, the first one was working fine. So let's go to the second one, 10 to 1. Okay, so we start off with 2 people, and on day 1 we have 4 people. That's correct. Day 2, 6. Day 3, 8. Day 4, 10. Okay, the reason why is actually because we're trying to see how many days it takes to exceed the population, but we only went as long as less than, and it should be as just less than or equal to. All right, so let's take this away here and try it again. Okay, so let's go 10 to 1. This should be 5. Yep. All right, and let's try it again for 750, 1, and 5. Now, whenever you make a change to a program, like to make it work for a certain test case, you should go back and test the previous test cases because they might not actually work anymore. So this should be a 4. Still correct. Okay, good. So the next thing to do is to go into Waterloo's online grader and put this in and see what happens. All right, and also we'll clean it up and get rid of the we'll get rid of the test code there. All right, let's see what happens. All right, so here we are in the online grader. I've loaded it up, and let's go to submit, see what happens here. Okay, that looks like the correct one. Okay, and just got to refresh this page. Okay, so far so good. Okay, looking good. Got a few left. Man, how many different test cases could they have? All right, so looking good. And then just 2 more. All correct. So there you go, 15 out of 15 on J2. All right, so again, I will post this into GitHub. The link will be in the description if you want to see the actual source code. If you have any questions, please put your questions in the comments. Remember to like and subscribe. Thanks for watching, and I'll see you next video.